Firstly, quiz 2 is happening on April Fool's next Wednesday. It's not a joke, okay? It's happening. Good news is it will only cover materials from week 3. Okay? It will only cover materials in week 3. So things happen this week, leave it later. Okay? Leave it later. So next week in the quiz, there will be only directional derivatives, second derivative test, and Lagrange multiplier. Okay? And then, so this is a minor thing. A more important thing is the midterm, okay, the arrangement for midterm. There will be 2 sessions in your midterm this year. Firstly, on that day, on the 26th of April, you need to log in onto your work. There will be a special assessment called midterm, okay? And you click into that, there will be a bunch of questions that you need to answer. So part of the assessment comes from doing special questions on work. Does it make sense? No worries, I will write a separate email later, but I want to let you know at the moment. That's session 1. Session 2 is a written examination, as usual, except it's shorter. So instead of 2.5 hours, you will have half of it only. So I presume it will be a shorter examination. And you will do it at home. Okay, you will do it at home. And then, okay, this is more important, no cheating. In the sense that don't do it in groups. Do it yourself. And don't risk your university degree just because of a midterm in calculus, okay? It's not worth it, okay? There's no point of risking your entire degree from cheating in a calculus midterm, okay? Does it make sense, okay? And, okay, regulation. We're still writing the regulation. I mean, I don't know, I always say that it's not an easy thing because there are 10 teachers and 10 people with 10 different opinions on the same thing. And we're still writing the regulation, but this is basically the format. So you need to do half of your mark for midterm come from doing special questions on work. The other one is come from written examination that you do at home. That you do at home, and we're still writing the regulation. Okay? But I want to let you have a preparation of how it will look like. In particular, yesterday there was something ridiculous happened. I got a message from a teacher that I barely know from my old high school. You can imagine I graduated from my high school many thousands of years ago, okay? And I suddenly get a message that apparently her son is doing calculus at university. And she claimed that, her son wanted to ask me some homework question. Okay? But then it turns out it's not homework. Luckily I discovered that a lot earlier than I think it's not homework. Okay? So I sent her a very serious warning that this can risk your entire university degree. Okay? Don't take your risk. Don't take the risk. It's okay to fail in this, okay? It's not okay to cheat and have misconduct in your degree. So, does it make sense? Okay? But regulation is still being drafted, okay? It's still being drafted, and then we have decided how to supervise you to do your examining at home yet. We think of a lot of possible ways, but none of them are perfect. So in particular, you will not do your midterm physically at the university, okay? Does it make sense? No worries, I will send a more detailed email once we have some agreement on how to regulate it. Okay, that's it. i.e. questions in the first 3 weeks. Let me tell you the truth. The truth is, if you can overcome question 1 to 8 here, then you can tell yourself that you're fine with the materials in the first 3 weeks. Okay? this milestone in some sense, okay? So if you can overcome question 1 to 8 here, then you can tell yourself that, okay, week 1, 2, 3, I'm done, okay? I'm happy. Okay, let me begin. The first thing is a loose end that I didn't finish last time. That is, we did second definitive test last time. And then also, well, you probably have done your homework already. And then, there's a case that we didn't discuss. That is, what if B equals 0? I.e., what if the determinant of the Hessian matrix equals 0? Then I told you that you have to do it by hand. How? Okay, what do you mean to do it by hand? This is an example. Consider the function, okay, this. Show that CO0 is a critical point of F, and the determinant is a local maximum, minimum, or saddle point, okay? So firstly, you find the critical point. So to find the critical point, then just set up fx and fy both equal to 0. But then in this case, it's actually quite easy because if you differentiate with respect to x, then you get 4x cubed. And then the other one, you get minus 4y cubed. And then if you set both of them to be 0, then you don't have too many choice. The only choice is xy equals 0, 0. Is indeed the critical point, okay? It's the critical point. But then what is the trouble? Okay, 0, 0 is the critical point, that's good. But then what's the trouble? The trouble is something cannot spell. Is that how you spell it? Trouble? Is that how you spell it? Something cannot spell. It doesn't look like trouble. But anyway, I don't have enough. Okay, drop me an email after class. Of what I've done here. Okay, let me say problem. If you can spell trouble, you can use spell trouble. Problem. What's the problem? The next thing you try to do second definitive test, but then the first thing is what's the Hessian matrix? The Hessian matrix in this case, okay, indeed equal to the CO matrix. Check, okay? Check. You can check that. In this case, the Hessian matrix is the CO matrix. So D equals 0, okay? So D is 0. So D is the determinant of CO matrix, so 0. So hence, second definitive test is inconclusive. Does not tell me anything. Alright. Firstly, second definitive test is inconclusive, imply that you need to do other things, okay? Does not imply that you are going to tell me that, it's inconclusive to stop. No, okay? You need to figure out whether it's a maximum, minimum, or saddle point by hand, okay? Okay, so how do I analyze this? Okay, so at 0, 0, at the critical point, what's the value of f? What is the value of f? What is the value of f? At 0, 0, what is the value of f? 0, okay, good, okay? 0. Therefore, 0. So at the origin, the value is 0, okay? At the origin, the value is 0. Okay, how do I determine whether it's a maximum or minimum point? I need to compare the size of it with its labels, right? So it's a maximum or minimum depending on is it larger than the guys around him or the other way around. Okay? So let me take a point around it. Let me take this, okay? Take this point. So let epsilon greater than 0. So epsilon is a fancy letter in Greek that mathematicians use it for denote small number. Small number. You can use A. If you wish, you can use A. I use epsilon just because I'm a mathematician. Okay, let epsilon be greater than 0. Let me take the point, consider this point, epsilon, comma 0 on the x-axis. Is that okay? Then what is the value? What is the value of this point? F epsilon 0. By the definition of F is epsilon to the 4. Right, epsilon to the 4. Is that okay? Epsilon to the 4, is it greater than 0 or less than 0? Greater than 0. Where epsilon is positive. Epsilon to the 4 is still positive, right? Okay. So, but what is 0? 0 is F still 0. So what have we done? We discovered that there is a neighborhood point that is greater than F still 0. Therefore, F still 0 is not a maximum. Does that make sense? I can find a guy next to him that is taller than him, so he's not maximum. Right? This is what I'm doing. I can find a guy next to him that takes value greater than him, so he's not maximum. Does that make sense? Okay? Is that okay? So the point number 1. Okay, let me take another point. Let me take another point. What is this point? This point is 0 epsilon. F0 epsilon. What's that? What's that? What is this? What is F? F is x to the 4 minus y to the 4. So what is this? Minus epsilon to the 4, which is positive or negative? Negative. Okay. Okay. So what have I done? I show that I can find a neighborhood. I can find a neighbor of the origin that is shorter than F0. Therefore, I can find a guy that is shorter than him, so he is not a minimum. Does it make sense? I can find a guy shorter than him, so he's not a minimum. Hence, S00 is neither a maximum nor a minimum. In mathematics, we have a term for this, we call it so hence. So it is a saddle point. This is what I mean by check by hand. Okay? You pick some label of the origin. Some of them greater than it, some of them less than it, so it is a saddle point. Or the other way around, if you discover that any neighborhood, any guys around it is taller than him, there is a minimum point. Does it make sense? I still don't understand why people say that I teach too fast. I still worry that I cannot finish my curriculum. And then, you know that next week there will be only one lecture. Here you have something like that. Okay? Something like that. And then so you have a holiday on Friday. We don't have that much time left if you think about it. So, anyway, so does it make sense? So this finished the story. So you pick a point, then you realize that this point is taller than him. You pick this point, you realize that it's shorter than him, so it's neither a maximum point or a minimum point, hence aka also known as saddle point. Okay? So next, okay? Are you ready? We are about to forget everything about differentiation. We start integrating stuff, okay? Integral calculus. Okay. So first of all, in calculus 1, you learn, I hope you learned, calculus of integration of one variable function. And then in particular, you learn that every function can be written as a Riemann sum, okay? So what is a Riemann sum? It's an infinite sum, okay? It's an infinite sum. If you have forgotten what that is, okay, roughly it's like this, okay? Roughly it's like this. And also it has some meaning, it's geometric meaning. It's the side area of under f, under the curve y equal fx. Okay? So let me just try to recall your memory. What is Riemann sum? I try to compute this area. How do I compute this area? Firstly, I chop this side into a lot of rectangles, okay? And then what is this guy here? This is the area of a rectangle. Okay? The height is f, okay? And then the width is delta xi. So the sum of a rectangle is this. And now you add all the rectangles, okay? And you get the area of the approximate sum, okay? But lastly, you want the width, because this is just an estimation. You want the width to be as small as possible, so you want to take delta xi to go to 0. That d is the area. Does it make sense? Does it bring you the memory of what you did in calculus 1? What you did is you chop this off into a lot of rectangles. So this is one rectangle. Adding all of them together, you get this. But then this is just an estimation. To get the actual area, you want the width go to 0. But sometimes for convenience, we take the width to 1 over n, then we can n go to infinity. Okay? The story is very similar here. Okay? So suppose you're integrating over a region. Okay, suppose now you have a region. You have a region. So you have a region. Let me call it R. Region. R. Which look like this. Okay, D is how it looks like. So D is also R. This R. Then you chop, the first thing you do is you chop off this region into a lot of rectangles, okay? It looks like square, but not necessarily. Okay, rectangles is fine, okay? So you chop that off into a lot of square. Then, this delta xi, so a little bit of increase of that xi is delta xi. A little bit increase of y is called delta yi. The difficult question, what's the area of this guy? Not I, it's J, sorry, J. Delta yj. Okay? So what's the area? The area is width times height. Therefore, the area is delta xi times delta hyj, which is a little area, so we call it delta aij. So D is my delta aij here. Okay. You read that on the other side. Okay. So you look at a very small piece of your region, which is a rectangle. Why rectangle? Is convenient. There's no stabilized reason for that. Rectangle is just because it's convenient to do it. So now it's just the region. There's no function yet. Okay? It's just the region. I chop out my region into a lot of small rectangular pieces. Now what is my function? My function is fxy. Okay, fxy. And then in week 1, I told you you can visualize a function in 2 variables by the surface z equal fxy. That's the way about. Okay? Z equal fxy is a surface. So the wet thing is a surface. So therefore, so this is the area, delta A, times, okay, times f, so fxi, yj, times delta aij. So it's the base times the height, right? Therefore, this is the volume of a little cylinder. Okay, I call it cylinder, even though the base is a rectangle. Does it make sense? Okay, so you have a base, which is delta aij, and times the height. What is the height? The height is given by f. Okay, given by f. So if you multiply them together, you get the volume of this guy. Of this, I call it cylinder. Okay, I can't find a better word for this. Does that make sense? It's okay. So this is the volume of this little tube, okay? It's okay? So this is the volume of this little cylinder. Now, what you do next is try to add all this volume together. Then what do you get? And then you get the volume of the entire thing. Okay? That's the idea. So you have a cylinder here, cylinder there, add them together, you get the volume of the entire thing. So let me write it down. So the volume of the solid between the surface z equal fxy and above the region or over the region, R, okay? What's that? Okay, what's that? So I know the volume of one little cylinder. Volume of one little cylinder is given by this xi, yj, delta aij, right? But this is just one of them. So I need to add all of them together to get the entire volume. So I need to sum. We will see there's a double sum, okay? Because there are I and j for you to sum. You need to sum in the x direction and y direction. Okay? Does it make sense? Okay? The volume of the entire solid is given by adding all this little cylinder volume together. But then this is a lie because this is just an estimation. This is just an estimation. The ideal situation is you want delta xi and delta yj to tend to 0. So therefore, it's not the end. You take limit of when delta xi and delta yj go to 0. It means that delta aij go to 0. Okay. Delta aij go to 0. Okay, and then so this is the volume of the solid between the surface set equal fxy and over the region R. And this guy has a notation. So this is the definition. Definition of what? Okay, definition of this. It looks horrible. Double integral fxy dA. Okay, this is the notation. So wherever you see, so the upshot is this notation means nothing else than the volume of the solid between the surface F over the region R. Okay? So the double integral is defined to be the volume of the solid between the surface fxy over the region R. Is point number one. Okay. Is that okay? So what is dA? dA is a shorthand. It's a shorthand for dx dy. You know what delta aij is delta xi delta yj. So dA is a shorthand for dx dy. And it does not matter because different human multiply area of a rectangle in a different way, so it does not matter whether it's dx dy or dy dx. Okay, so definition one is just, well, writing this again, so this is definition one. But I never claimed that the limit exists, okay? So if the limit exists, okay, if the limit exists, we call it integral, for the obvious reason. If the limit exists, on the right, sorry, not on the left, on the right, I can't distinguish left and right anymore. On the right, exists. So theorem 2 tell you what you can integrate. So this is not going to prove, but good news is all continuous function are integrable. All continuous functions are integrable. So I define how to integrate a double integral. At least I need to know what I can integrate, right? And then at least continuous function I can integrate. Okay. I want to make one more remark since we are faster than any other human being anymore. If you do not understand this remark, it's okay. I want to make this remark to let you know that an easy fact is due to Labat, a mathematician in the 20th century. And then Labat has something called dominated convergence field. Dominated convergence field. Okay. Dominated convergence field. So if today after the class your friend asks you what do you learn today, dominated convergence field, you freak them out, okay? Okay, so basically, it's a very subtle question in mathematics. That is, here, in my definition, I'm adding I over I first and then fj, okay? So your question is, can I do the other way around? You see, so in the above definition, let me write in this way, okay? Is it true that summing over I and then j and then, or summing over j and then I are the same? Indeed, this is a huge trouble, okay? This is a huge trouble. The reason is, there are sometimes it's not true, okay? There sometimes it's not true. And I will tell you when is that true, okay? This is a consequence of the Lambert-Dominant convergence theorem. That is, if f is continuous on a bounded region, so I a boundary, a region with boundary, with a proper boundary, on a bounded region, then summing over I and then summing over j is the same as the other way around. So I just put the limit here. Okay? So whichever way you do it, it will get the same answer. In general, this is not true. But you don't have to worry too much about that. This is a calculus course. This takes human being 200 years to discover this. Okay? But then you should be aware. Otherwise, the next video you will think that, oh, what is that? Okay? You thought it's always obviously true, but I'm telling you that this is not. Okay? It's actually people start doing a lot of calculus, and at a certain point they realize that all these seemingly obvious things is actually false, and they start recovering this. So initially they will think that I and some j, I'm adding the same thing, so it's the same. But then it turns out whenever you start taking them, things go wrong, dramatically wrong. Okay, so for instance, integration over rectangle. What about over rectangle? Suppose your region is a rectangle. Suppose now R is a rectangular region. Okay? That's not rectangular. It's more rectangular. So what does this notation mean? It means that X is between A and B. So X is between A and B. So this is X, okay? This is X. And then the second pair is Y. Y is between C and D. Okay? So this is my R now. Okay, so what does this theorem want to tell you? This theorem wants to tell you that if f is continuous on this rectangle, so now I draw a rectangle like this, okay? It's continuous on this rectangle, then integrating with respect to x or y first does not matter. So for example, the middle guy, you integrate with respect to x first and then y. And then the last guy, you integrate with respect to y first and then x. And then if f is continuous on this rectangular region, then dominated convergence theorem applies, and will imply that integrating with respect to x or y first does not matter. So basically, if you want, if you're engineers, for example, if you need to do any report, mathematical report in the future, and then sometimes you need to switch to infinite sum, or sometimes you need to switch, for example, to double integral, for example. You want to switch the order of integration. Then you're not too sure whether you can do it, put it down, dominated convergence theorem, stop, and then it works. So basically, this is the most powerful theorem that will imply you can switch everything, or anything sensible, anything sensible. In Stewart, in your textbook, this theorem that you can integrate with respect to x first and then y, or the other way around are the same, is called Fubini. But I think, okay? So Fubini literally tell you that you can swap the order integration. You can integrate with respect to x first or y. But then I think this is too simple to be called Fubini. Fubini is much deeper. Okay? I actually gave you the full power of Fubini later, but anyway. I think it's too much to call it Fubini here. Fubini did something a lot more amazing than this. Okay, so if you're not a theoretical guy, okay, if you're not a theoretical person, then now we start doing math, okay? Calculus, okay? Example 2, evaluate this integral over of this function over the region. Can you read this? This is a fancy way to say x is between 0 and 1, y is between 0 and 2. So this is really saying this. Okay? So I worry that when you go to do your past exam or your web work, you don't know what does that mean. It's just a lengthy, fancy way to write this. Okay? So you look at what are the conditions here of x between 0 and 1, so it means this, and y between 0 and 2, so it means this. Are you ready? We're going to do our first double integral together. EA, okay? So, for example, if I want to integrate with respect to x first, so for example, let's integrate with respect to x first. What does it mean? It means that I'm going to do dx dy. Okay? So dx we do first. Is your function. Then for rectangular region, your life is very easy. Literally, so you need integration limit, right? How do you fill in the integration limit? For rectangular region, so you integrate with respect to x first. For x is between 0 to 1. So 0 to 1. Okay? So you integrate with respect to x first. And then y is between 0 to 2. So 0 to 2. Is that okay? You integrate with respect to x first. So what is x? X in this case, in a rectangle, is just from 0 to 1. And then integrate with respect to y. Y is from 0 to 2, so you get this. Okay? Have you forgotten how to integrate things? Okay, so let me ask you a simple question. How to integrate this? Order of two functions, how do you integrate this? Integration by part, okay? So to integration by part, you need to differentiate something, integrate something. What will you differentiate? We learn a slogan called liège, okay? Liège. If you didn't come from my class, you don't know what I'm talking about, but anyway. Liège. And watch the video yourself, okay? So in this case, okay, exponential comes the end, therefore, we differentiate x, integrate exponential. Okay? And then differentiate, you get 1. integrate, you get e to the x plus 2. Okay. And then eventually this again, you get 0. Integrate this again, you get the same. Plus, minus, plus. You do this, therefore this is x e x plus 2 minus e x plus 2. That's the way about. Okay? So similarly here, x is not 2, it's y. But when you integrate with respect to x, y is kept as a constant. Okay? So let's do integration by part. So di, do we differentiate x, integrate this. Okay? Remember, you're integrating with respect to x, so d is a constant. So y is constant. In other words, imagine y is 2. Then you now start differentiating d until this die, and then integrate, plus, minus, plus. Okay? Therefore, okay, the thing outside I don't touch. 2 still, dy I don't touch, okay? The thing inside, after I integrate this, I get x e x plus y minus e x plus y. You're integrating with respect to x, right? Therefore now this is a definite integral, so you can do substitution. So x equals 0, x equal to 1. Form a good habit. I know usually you just write 0 and 1 there, but now because we have many more variables, so it's a good habit that you remember you substitute x or y equal to 1 or 0. Oh, in any case, okay, I didn't do anything magical. If you come from other class, then do it in your usual way, okay? It's just integration by part. Okay, so after you do this, then you substitute x equal to 1, then you get e to the 1 plus y minus e, okay, good, 1 plus y, minus, substitute x equals 0, you get 0 minus e to the y dy. So I'm just doing the usual thing. Substitute x equal 1 minus substitute x equals 0. Is x equal 1 is x equals 0. Okay? Good news, die, and then, so at the end you have just e to y dy. And if you do not know how to integrate this, then don't let me know. Don't let me know. Okay? So y equals 0, y equals 2, okay? So at the end you get e to 2 minus e to 0. So it's e to 2 minus 1. So we evaluate our first double integral. Okay. But okay, so does it make sense? You just need to keep track. Firstly, you need to remember how to integrate things. Secondly, you need to keep track with your variable very carefully. So are you integrating with respect to x or y? Wherever you're integrating with respect to x, regard y as a constant. Okay? Imagine it's 2, okay? 5, okay? Whatever. Okay, here I give you alternatively. If I integrate with respect to y first and then x, okay? So in the solution that I gave upstairs, I integrate with respect to x first and then y. What if I do the other way around? If I do y first and then x, okay? Then you realize that you get the same answer. Okay, it's good. Is that okay? Okay, if you are happy with this, then we can break. Above the square, minus 1, 1 times minus 2, 2, okay? So pictorially, which will not horrible, but anyway. So this is the region R, okay? And then elliptic parabola, whatever is that, is a surface. So this, okay, this z equals to 1 minus x squared over 4 minus y squared over 9. Oh, by the way, okay, this is the elliptic parabola, whatever that shape is that, okay? Now we're asking what is the volume what is this volume under the surface but above the region? Okay, what is this third? So what is this guy? Okay, I'm terribly enjoying things. Okay, so what is the volume of this solid? Okay, it does not matter what the surface is. Okay, so you know roughly what the pictorial looks like. Okay, so volume of the solid below what? Below Z equals to 1 minus x squared over 4 minus y squared over 9 over the region R. By definition, this definition, okay? By definition, is the double integral over R of what? Fxy, this is my fxy, and then dA. So if you're not too sure why this is the case, look at your definition on page 1, okay? Page 2, actually. Page 2. So what do you mean double integral? Double integral, by definition, is the volume of the solid between the surface Z equals fxy and the region over the region R. So here, the volume of the solid below this and over the region R is given by this. It's just definition. Okay? Okay? It's just definition. In general, volume of the solid below Z equals fxy over the region R equal to this. Okay, so now, so I integrate with respect to x first or integrate with respect to y first? The answer is does not matter. So suppose I want to integrate with respect to x first. So I still have this guy in the middle. 1 minus x squared over 4 minus y squared over 9. X going from, so you look at x, from minus 1 to 1. And then y from minus 2 to 2. If you want to try yourself, okay? I give you 2 minutes to try yourself. Okay, I'm going to do this ridiculously slowly, okay? So minus 2 to 2 dy I don't touch. I integrate the guy in the middle with respect to x, so I get x minus x cubed over 12 minus xy squared over 9. X equal minus 1, x equal 1. Okay, so if you evaluate at 1 and a minus 1, I hope this is what you get, okay? I hope this, let me use red. 11 over 6 minus 2y squared over 9. Do you get this? I need some confirmation. Do you get this? Mr. Chen, do you get this? Do you calculate? I hope it's alright. If it's wrong, then you probably can figure it out yourself, okay? Okay, finally, you integrate with respect to y. So you get 11 over 6y minus 2y cubed over 27. And now you substitute y equal minus 2 and 2. And I'm not going to do the rest. The only thing remaining, I will only have a mistake in doing this thing. Okay. My thing is something like this. Check. Okay, check. Go home and check. Check. So the numerical answer is important, but not the most important, okay? You need to know what you're doing. Check, okay? I can be wrong. I haven't integrated a single solve for a while as well. Is it wrong? Oh, okay, good. Thank you for the confirmation. I need someone to confirm with me every single time. Okay. So, okay. Next, the next one is an interesting example. It's a very interesting example. I call it choice method. So, just now, I say that theoretically, by dominated convergence theorem or Fubini, you know that integrated with respect to x and then integrate with respect to y, or the other way around to give you the same answer, right? So theoretically, this is correct. But technically, it could be different. For example, this. Let's look at this. This integral, I integrate over this region, CO1 to CO1, okay? CO1 to CO1 times CO1. For example, if I integrate with respect to x first, okay, with respect to x first, then I will get this. Then the first one easy, by integrating by half, by IBT. Then I get this, okay? Then you spread that out, then you get the last equation that you have there. Then you will get, oh dear, why do I have improper integral? Then improper integral, I need to calculate that carefully and blah, 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 blah. Okay? They will say, oh dear. Okay? It's just painful, okay? It's just painful. I'm not saying that it does not work, it works, but it's painful. If you do it the other way around, what if, okay? What if I do the other way around? So if I integrate with respect to y first, and then x, okay, and then x. So what does it mean? It means that, okay, integrate r xy e to the xy squared dA. Integrate with respect to y first, y, x y e to the xy squared. And then still to 1, okay? Do you know how to integrate this immediately? With respect to y. Can you see the antiderivative of this immediately? So what do we differentiate to get xy e to the xy squared? I want to be perfect. Differentiate this with respect to y. Think about it. What do you get? You get itself, and then by chain rule you have an extra 2xy. This is the thing about. Agree? Do you see this? If you integrate this with respect to y, okay? If you cannot believe this, try to differentiate this with respect to y. If you differentiate this with respect to y, you get itself, and also the guy coming from chain rule, which is 2xy. So 2xy, this 2 and this 2 cancel xy this time. So y equals 0, y equals 1. And then so now you substitute y equals 1, then you get e to the x over 2. And then minus y equals 0, you get 1 over 2. And the rest are easy because it's just ex minus x equals 0 and x equals 1. We check, which I hope is correct, is half e minus 1. Can you see that in this example, when you integrate with respect to y first, you get a dramatically easier integral to integrate. Whereas the other way around, you have improper integral. Yeah, it's doable. It's doable. So the remark I want to make here is, okay, remark, theoretically, integration order does not matter. You should be able to get the same answer. But at a technical level, technically, they are. In other words, one of them can be a lot easier to do than the other one. So can you see from this example that theoretically it doesn't matter which way you do it, okay? But technically, one of them is a lot more difficult than the other one, okay? Now, of course, your next question would be, how do I know which way around? So I do integrate x first or integrate y first. Then this is the whole subject for this week, okay? The whole subject of this week is to build you a sense of which way should you do first. Actually, can you read my writing? It's okay. For people from my class, you have tolerated for an entire semester, it should be fine. Okay. So before I start building you the sense of which way around, which should you integrate with respect to x first or y first, let's integrate things over just other than just rectangles. we have just integrated things over rectangle, right? But there are other regions live, okay? So next topic, integration over general region, okay? General region. And number one, don't be ridiculous. I never remember which one is type 1 and type 2, okay? Couldn't catch, okay? Which one is type 1 and which one is type 2, okay? Couldn't catch. So, okay, part one. Suppose now your region is not a rectangle. It's something weird, like this, okay? So, I will do it twice, okay? I will do it twice. So, look at the region, type 1 region on the left, okay? I will do it twice. So, firstly, you integrate from here to here. This is the vertical direction. Oh, by the way, reminder, y is the vertical direction. X is the horizontal direction. Bear this in mind. You cannot believe this is a lot easier. Okay? You remember, y is the vertical direction. X is the horizontal direction. Okay? So, if you go from this, and then this, firstly. So, firstly, you go vertical direction. That means that you're integrating with respect to y of this function. Okay? You firstly integrate with respect to y, but from where to where? From where to where? From here to here. From here to here. Does it make sense? This is the start. This is the end. Okay? From where to where? From vertically, from the lower curve to the upper curve. The lower curve is y equal g1x. The upper curve is y equal g2x. Is that okay? So I firstly integrate with respect to y first. It means vertical direction. In the vertical direction, what is my region? From here to here. Here, y equal g1x. Upper, y equal g2x. So from g1x to g2x. Does it make sense? Is that okay? And then we integrate from with respect to x, which is a lot easier. If you look at x, where does it go from A to B? A to B. Is that okay? So every time when I draw a region, then the first thing I will detect is, oh, so it's integrate from here to here, firstly. It's the vertical direction, that means that I integrate with respect to y. From where to where? From the lower curve to the upper curve, so y equal g1x to y equal g2x. And then I go the horizontal direction, which is easier. I just need you to look at the two ends, which is A and B. Okay? The other one, okay? Suppose you have a so-called type 2 region that is given by something like this, okay? Then the way to do it is, first I go from here to here, and then I go from here to here. So first I go horizontal, that means that I'm integrating with respect to x, okay? I'm integrating with respect to x. And where is my starting point? My starting point is here. Start. And this end. Okay, this end. So my starting point is x equal h1y. And my ending point is, ending curve is h2y. I'm integrating f with fxy. And then I go vertical. Vertical, I just need to look at the two endpoints in the y direction, C and D. no worries. This is the only thing we're going to do by the end of today, in the rest of today. How to set up the integral correctly. Okay, let's do this. Is that okay? Can we copy down? Okay, example 5. Find the integral r of x squared plus y squared dA, where r is the region bounded by y equal to 2x and y equal to x squared. Step 0 or step 1, whatever we call it. Step 1. Sketch your region. There's no way you can do any of this kind of question without sketching the region. Even though when you read whatever solution, whatever textbook, they never sketch you the region, they have done it in their head or whatsoever. Okay? They just don't show you. So a lot of people think that this chapter is very mysterious because they don't see a single region. Okay? But then actually there should be. Okay? Do you know how to sketch this? Okay, let's sketch this. So firstly, I have y equal to 2x. Okay, y equal to 2x, whatever that is, it's a lie. Okay, it's y equal to 2x. Although I made it look like y equal to x, but who cares? Okay. The other thing is y equal to x squared. So it's a parabola. Okay, parabola. So the region between these two curves is this. Okay? Is that okay? So the first thing you need to figure out is, okay, as you did in calculus 1, what this point? Well, of course I know this point is the origin, so 0, 0. How this point, okay, you need to do a little bit of calculation. Can you see it? When do they intersect? When you equate these two equations, what do you get? X squared equal to 2x. So x is 2 or 0. So x is 2. And when x is 2, the other guy is 4, okay? Because y equal to 2x or y equal to x squared. Is that okay? Do we need to do this kind of calculation in detail? Probably not, okay? I hope not, okay? But let me know if you get stuck in this kind of thing, okay? Next question. Do you want to integrate with respect to x first or y first? Up to you. So for example, okay, let me do integrate with respect to y first, y, because well, everything is written in y with something nicely, okay? So it's not necessary, but let me do. So what I'm going to do is I'm going to do this first, and then do this. Okay? Therefore, dA. So I do vertical first. That means that I'm going to do dy first, and then dx of the same function. Okay. Now, from where to where? In the y direction, I go from the parabola to the straight line. Okay? From the parabola, which is y equal to x squared, to the straight line, which is y equal to 2x. Okay, if you really need help in this kind of thing, so just write down the y here, okay? Okay? It's not a mistake of writing a y equal. If that helps, okay? If that helps. Okay? Does that make sense? In the y direction, you go from the parabola to the straight line. So from x squared, y equal to x squared to y equal to 2x. Okay? How about x? In the x direction, from where to where? You look at the two endpoints. What are the endpoints? What are the endpoint in the x direction? In the x direction, what is the endpoint? From where to where? From 0 to 2, okay? That's it. This is the integral. Then the rest, okay, let me do one more step, okay? So firstly, you integrate this with respect to y, so therefore the guy in the middle becomes x squared y plus y cubed over 3. And then you get y equal x squared, y equal 2x, okay? So therefore it's integral from 0 to 2, 2x to 2x cubed plus ax cubed over 3 minus x to the 4 plus x to the 6 over 3 dx is x, y. The rest exercise, okay? I hope you remember how to integrate polynomial first, okay? But the point is, the numerical answer, I don't really care. Okay, it matters, okay? It matters, it counts some credit. But most of the credit come from whether you write this down correctly. It's okay if I leave it like this, because now it becomes an integral of single variable. It's just a matter of whether you integrate this correctly. It's a polynomial, come on. Okay? But the hardest thing is you need to write down this limit correctly. Is it okay? Okay? Okay. So this is a cool example. I will do it tonight, and it will be available into cool. So I'm going to do example 7. Example 7. Evaluate the integral of this where R is the region, okay? If you don't know how to read this kind of thing, so these are the most key piece of information, okay? X is between square root of y and square root of 1. Oh, sorry. I'm not saying anything. Square root of 1 is 1, okay? And y is between 0 and 1. Okay? So step 1. Sketch the region, okay? There's no chance for you to get any kind of things like this correct if you do not sketch the region. Do you know how to sketch this kind of thing? So firstly, you want x to be above square root of y. So what is this, okay? You know what is this? It may look unfamiliar. I'll say look more familiar now. This will look more familiar. Y equals x squared. So, this is x equals square root of y. Okay? Or aka y equals x squared. Is that okay? It's just a very familiar curve written in an unfamiliar way. It's like this curve wearing a mask, okay? Just to see. So, okay. So now, x is greater than or equal to square root of y. Difficult question. Is it this or this? Is it on the left or on the right? On the left or on the right? X is greater than this, that means that x coordinate is huge, okay? So that means that it's this piece, okay? Does that make sense? Okay, so this is x greater than or equal to the square root of y. X coordinate need to be huge. Okay? It's a lot easier than you think, okay? And then finally, y is between 0 to 1. So y is still is 1. So y is between 0 to 1. So ultimately, your region, let me move it into. So ultimately, your region is given by this. Is that okay? So y is between 0 and 1. So it has to be within, the vertical distance has to be between 0 and 1. And then x is greater than or equal to the square root of y. So this is what you get. And also this x equal to 1, okay? Because you also know that x is at most 1. Okay? This lead practices. Okay, this lead practices how to draw the region. But we never asked you to draw very difficult curve or whatever. This is just power. We need to figure out what all this important means. Okay. Let me write down an attempt. What's the attempt? Okay? So there are two ways you can do this. You can integrate with respect to x first and then y, or the other way around. So suppose I integrate with respect to x first and then y, so it means that you go horizontal and then vertical. Attempt is first go horizontal and then vertical. Then what is my integral? Okay, my integral. So I integrate with respect to x first and then y. So firstly, I go from here to here. Okay? From here, let me draw this. But I don't recommend you to draw this. Right? Okay. Let me draw two diagrams. Let me copy. Copy and paste. You think about in whatever way you find more comfortable. So, okay, firstly, if I do horizontal, that means that I go from here to here. I go from my parabola to the straight line. Okay? What is my parabola? My parabola is x equal to square root of y. Okay? Agree? And then what is this vertical line? What is the equation of this vertical line? X equal to the vertical line 1. Okay? And then I go vertical. Then in vertical direction, then you get 0 to 1, okay? You say okay. Okay? So if you go horizontal first, then it means that you go from the parabola to the straight line. The parabola is x equals square root of y. The straight line is x equal to 1. Then after you figure out this, then in the y direction, you look at the endpoint 0 and 1. Okay? Do you see a trouble here? The trouble is, this is correct, okay? This is correct. The trouble is, I have no idea how to integrate this. X cubed plus 1 square root. Even you put it into your favorite integral calculator.com, it's not good. I know all your tricks. I'm not much older than you. I know all kind of tricks to how you do your homework. Okay? So even though you put it into integralcalculator.com, you will say, oh, I cannot do it. Okay? So because we don't know how to integrate x cubed plus 1 square root. Okay? So therefore, this one. Theoretically, this is correct, but it just, by hand, I don't know how to integrate this. So it's a technical issue. So that's why That's why instead, let's do this attempt. So this attempt. Okay. And then let's try the other way around. Let's try the other way around. So the other way around, the other way. That means you go vertical first, and then do horizontal. So it means that you do integration with respect to y first, and then do horizontal. Okay? So 1, 2, 1, 2. Okay? So in this case, the integral you integrate with respect to y first and then x, okay? So in the y direction, you start from here to here, okay? What is the bottom line? The bottom line is x-axis, aka y equal to what? Y equal to x-axis. What is the equation for x-axis? Y equal to 0, okay? There's no main choice here. And the function is still the same. From y to 0 to the parabola, what is the equation of the parabola? The equation of the parabola is y equal to how many? Y equal to x squared. So it's from y equal to 0 to y equal to x squared. Is that okay? Okay, you go from the vertical direction, that means that you come from here to here. What is this line? Y equals 0. What is this line? Y equals x squared. Is that alright? Okay. If this is not alright, go home, watch this 20,000 times, okay? Or come to me. Okay, and then now you take care of the x direction. For x direction, you just need to take care of the endpoint. In this case, the endpoint is still at 1. So firstly, I integrate this with respect to y. This is super easy because, well, the guy inside has no y, so these are entire constant. So you just this times y do you see that this guy differentiate with respect to y, you get this. There's no technical whatever issue. He integrates this with respect to y. It's hard to integrate with respect to x, but to y is fine. But then after you do this, a miracle will happen. That is when you start to x squared, you get x squared. Then now, okay, it's okay. It's okay. Okay. Then now, integralcalculator.com can do it for you, or you should know how to do it. You know how to do it. You remember how to do it. Okay, we call your memory. Let memory time. Let u to be the most complicated guy. X squared plus 1. And du is 3x squared dx. Okay. And then also when x is, then you need to take care of the limit. When x is 0, then u is 1. When x is 1, u is 2. But you did very well in your final, so I'm sure you remember all this. So you get 1, 2, and then you have square root of u, and then du over 3. Therefore, this is 3 over 2, and then 2 over 9, 2, 1. So this is 2 over 9, 2 to the 2, check. These are just baby calculus. It's okay. So the moral or the upshot, okay, is when the first thing you can detect whether you should integrate with respect to x first or with respect to y first is look at your given fxy, okay, fxy. So the given fxy, do you know how to integrate with respect to x or y? For example, in this case, we realize that we're going to integrate with respect to y first because we don't know how to integrate x cubed plus 1 square root with respect to x. It's a very naive answer. So you can't do the one way, you do the other way. You can do both ways, it's very good, okay? And then you can do either way. Option is this. Okay. I love doing integration a lot more. I should find it. Good luck to you, okay, it's okay. Can I do just one more thing? Just one more little thing. The next question. I'm not going to do the entire thing, but then I will at least set up the integral. So Simon bakes a cake that is of the shape below. Okay, you can see this is a cake. Okay? The testing is a cake. And then it's below the surface, z minus cosine x squared plus 2. So in other words, this is the surface z equal 2 plus cosine x squared. And then above a triangle with vertices still 6, 2 on the xy plane, find the volume of the cake. Okay? So volume of the cake equals to the volume of the surface of below the surface, under the surface, z equals to 2 plus cosine x squared over the region R. When I put R, it's the triangle, so this is the region R. Okay? This is the region R. By definition, it's the double integral R 2 plus cosine x squared dA. There are no mathematical ingredients here. This is the definition of this guy. Okay? It's the volume of the solid under the surface, this, over the region R. Okay? Is that okay? This definition. Go to page 2, okay? They will see this definition of double integral. Alright? The next thing is sketch your region. your region. So step 1, sketch R. Yeah, I know it's a triangle, but I mean do it slowly, okay? So triangle. So what are the vertices of this triangle? The vertices are the origin 6, 0 and 6, 6, 2, so it's 12. So it's a right angle triangle. Is that okay? This is the triangle. Okay. Next step, integrate with respect to x first or y first. Then you ask your question, do you know how to integrate this with respect to x? Cosine of x squared. Integral calculator tell you that hopeless, okay? So, integrate with respect to x first will fail, okay? Therefore, we do y first and then x. Y first means you do the vertical direction, so this is the region. This is the region. So doing y first, that means like doing this first, and then do this. So do you understand why I do y first and then do x? Because I have no idea how to integrate this with respect to x. Cosine, if it is cosine x, fine. Cosine of x squared, hopeless, okay? Now to integrate this, with respect to y, that means I go from here to here. I go from here to here. The bottom line is the x-axis, aka y equals 0. Okay. Okay. I'm not going to finish the calculation, but at least I want to set up the integral. This is the function. How about this line? How about this line? What is the equation of this line? I don't want to do in details, okay? This is y equals to x over 3. I hope you know how to find the equation of a line. Not to mention a pass-through origin, okay? As with y equals some x, okay? Or is this some x then? When x is 6, then you get 2. So you figure out it's 6. You should check, okay? Check. Check. Is that okay? So this is from the horizontal line y equals 0 to y equals x over 3. Then you take care of the x direction. The x direction is from where to where? Now, what is the endpoint in x? This is 0. This x is 0. How does this x equal to how many? 6. Okay? 0 to 6. That's the integral. The reason why I prefer teaching earlier in the beginning, because the earlier thing is like algorithm. You apply this. This actually requires some practice, I think. Okay? So go home and try to evaluate this yourself, and then we'll check our answer on Friday. Good luck, okay?